Okay, hi everyone. So we are on the last question, question number 3. So a student carried out some experiments to investigate the displacement reactions of 4 different metals: copper, magnesium, cobalt, and chromium. So immediately I can see that there's 2 metals that are our syllabus, cobalt and chromium. So we need to look at the experimental results to be able to tell me what's the relative position. So over here, I'm just going to mark briefly because I want to see it. There is no change here. There is no change here, and there's no change here, there's no change here, no change here, and no change here. So I think that's quite expected because you can see that copper, it's generally unreactive and therefore cannot displace magnesium, cannot displace cobalt, cannot displace chromium. So I will safely say that copper is the least reactive. So let's see which one is the most reactive. So I think we go with what the knowledge we know. Okay, so magnesium generally quite reactive. We can see that magnesium actually displaces copper because a brown solid forms, that is most likely copper. A grey solid forms, that's most likely cobalt. And then the last one, a grey solid form, also most likely chromium. Alright, so over here I can safely say that magnesium is the most reactive. Now let's decide about between cobalt and chromium. So we can see that cobalt cannot displace magnesium, which is expected, and also cannot displace chromium. That means cobalt is less reactive than chromium, right? Let's confirm it. Can chromium displace cobalt? Yes. So you see, chromium can displace cobalt. So there's a reaction there. So we can safely say that chromium is more reactive than cobalt. Right? Okay, so let's look at the next question. So magnesium sulfate is colorless. Complete the tables to show the colors of the different metal sulfate solution. So you must worry, how do I know, right, all these things? Copper 2 sulfate you should know, but if you cannot, actually the answer is in the table here. So let's take a look. So let's take a look. Over here, we have copper 2 sulfate. So copper 2 sulfate, if magnesium is placed in copper 2 sulfate, I'll look at this one. Because when magnesium placed to copper 2 sulfate, right, what is formed? If I write it down, it would be copper metal, which is the brown solid. Let me zoom in for you. Right, it would be the brown solid, and this colorless solution is actually your magnesium sulfate. So that is, magnesium sulfate is therefore colorless. Next one, when cobalt displaces copper, this brown solid again is copper, and the pink solution should be my cobalt 2 sulfate. And then the last one, chromium, which also can displace copper. The brown solid is copper, and then the green solution would therefore be your chromium 3 sulfate. Okay, so this is a very important skill, that how to look at the experimental results to determine the color of the solution. So please keep this in mind. Right, so let me just write it again. Copper sulfate is blue. Right, this is, you should know this color, blue. Cobalt 2 is pink, and then chromium 3 is green. Okay, let's take a look. Next one. Displacement reactions is exothermic. Complete the energy profile diagram between chromium and cobalt. So I need to have the name. So it's exothermic. So exothermic energy release. So reactants has to be below. So products has to be below, sorry. So chromium and cobalt 2 sulfate will form cobalt metal, right? Remember, don't have the symbol behind. And then we have chromium 3 sulfate. Some of you might ask me, Joe, how do you know that it's chromium 3? You read the question gives it to you. Right? Then after that, remember, draw the activation energy. Right? And then remember our technique. Right? We draw the dotted line only from the reactant. Draw all the way. Right? And then all arrows start from the dotted line. So dotted line up here, and then from dotted line down. Make sure you touch all the appropriate lines, right? And the arrow direction must be correct, all from the dotted line. So I need to show the labels of the activation energy. So this is activation energy and this is enthalpy change. Okay, so if you want, you can spell it out, it doesn't matter. Okay, ionic equation I'll skip first, and the last one. Okay, so the student added calcium instead, and they observed fizzing. So fizzing is the same as bubbles form. So this is something that we discussed in class, that we need to be alert to this. That if, let's say for example, I add a reactive metal like calcium, so we got please stop calling me, right? And then this one here is calcium. This is within the first 4 elements. That means this will react with cold water, right? So that means why this fizzing occurs, right? It's not because of the displacement reaction, because calcium will displace, right? Because it's really reactive, right? But there's fizzing. So why is there fizzing? It's because the calcium is actually reacting with the water in the solution. So explain this observation. So since it's explained, since calcium is a reactive metal, so this is how we write it, okay? So calcium is a reactive metal, and as, right, and as calcium will react with water to produce hydrogen gas. You can also write that calcium will produce calcium hydroxide, but the most important one is the hydrogen gas. So you must say that it's a reactive metal, react with water, produce hydrogen gas. Alright, so I think I've taken a bit too much time for this. That is the end for this third question. Right, hope that has been helpful. Bye bye.